Hello, guys. I think so. We will part one. We will see the logistic regression equation and stop there. Our last seminar. There is the next part. We will see in the logistic regression. Okay. Instead of the predicting the value, we will see the next one is the logistic regression and the concept of the logistic regression. Okay. Let's talk of the mathematical model behind a logistic regression. The py equals to y equals to 1 by 1 plus e, okay, minus b naught plus b1 x. Okay, there is the logistic regression concept. We will see the sigmoid functions, logistic regression equation, and now we will see the logistic regression equation. The logistic regression model, p equals to y equals to 1 upon 1 plus e minus b naught and plus b1 x, where b naught is equals to intercept, b1 equals to coefficient, and x equals to input. The output is the probability of the class is equals to 1. Let me explain the part of the formula. The B naught is the intercept of the bias term. It is a shift that curve left or right. B1 is the coefficient or weight assigned to be input features X. It show how is the strongly that features influence the prediction. And it is the input features or variables. How it works, we will see. First, the model is the calculate functions, the fraction and the exponent to convert this the z value into probability between 0 and 1. This result is the p equals to y1 is the probability that the instance belong to the positive class 1. Examples, for example, if p equals to y1 1 and 0 equals to 0.85. It means there is an 85% chance the input belong to the class. Based on the chosen threshold, usually 0.5, the model will be classified the instance of the class 1. The probability is a greater than a threshold and otherwise is the class equals to 0. Okay. The transaction line we will see the result of the probability of the next. We will talk about the transition about the all the during of the training. Okay, next one is the we will see decision boundary, and there is the next topic of this session. What is the decision boundary and why we are using it is the decision boundary is a separate class. Once our logistic regression model calculate the probability that instance belong to a class, we need a rule assign the final class label. There is where the decision boundary comes in. Threshold for classification, in most cases we use a threshold of 0.5. The probability equals to greater than 0.5 class 1. Then next one is less than 0.5 class 0. This means the probability above 0.5 is the considered positive and the probability below 0.5 are the considered negative. This threshold can be adjusted depend on the problem. For example, in a medical diagnosis, we might to understand choose a lower threshold to catch more positive case. Graphical representation, we will see graphically the decision boundary is used to line or curve that separate the two classes on a plot of features. One side is a boundary is the class 0 and the other side is the 1. For two features, this boundary is usually a straight line, and for more features, it's become a hyperplane in higher dimensions. So, essentially, the decision boundary is what the model learns from the data to separate different classes and as accurately as possible. Okay. the prediction probability and assign the class using a decision boundary. Let's explore the different types of logistic regressions and the logistic regression training. How we will see. Okay, the next one topic we will see it is training logistic regressions. Model training logistic regression. Training a logistic regression model is all about the finding the best coefficients b naught, b1, bn, so that the model predict the correct class as accurately as possible. Think of the data model is the correct class accurately as possible. Think of like tuning a radio, you adjust the knob coefficient until the signal predict it as a clear as possible. What the coefficient? The coefficient in the model equals to p y equals to 1, 1 by 1 plus e naught, b naught plus b1 x1, b2 x2, and bn xn. B naught is the intercept, shift the decision boundary left or right. B1, B2 is the weight, measure the influence of each features on the outcome. The goal of the training is the find the value B naught, B1, Bn that makes the model most accurate. The concept, instead of the directly minimize the error of the linear regression, logistic regression use maximum likelihood estimate MLE. Idea, we want to set the coefficient that the maximize the probability of the observing that actual label in training data. In the other words, if the actual label is 1, we want to predict the probability to be as close to 1 as possible. If the actual label is 0, we want to predict the probability to be as closer to 0 as possible. The MLE help us mathematically formulate this idea. Functions measure how likely it's the model. We will specify the set of coefficient will produce the observed data. For the data set with a multiple observation equals to B naught, B1, Bn. uh, okay. N is the number of data points, Y is the number of the label observations. But the maximize the likelihood works if we focus on a probability rather than raw errors. It is naturally fits the binary classification setting. It ensures that the predicting probabilities align with actual outcome. Suppose a patient is actually has a disease Y1. We want the model to predict a Y equals to 1 as close to 1 as possible. MLA adjusts the weight to the predicted probability matches the actual label across all training data. Visualizing the model training, imagine the plotting a line or a boundary that separate a class 0 and class 1. Initially, the line is a random. As the coefficients are updated, the line moves. After training, the line is the position to best separate the two classes. The boundary determine this coefficient learned during a training. Random initial confidence, poor prediction, apply MLE means model updated coefficient and training data. Next one we will see the cost functions and cost function. Okay. The cost functions linear regression means square error, the log loss functions, cross entropy, their formula and all. First, the way to training a model, we need a way to measure how well it is performing. This is done using a cost function which tell the model how working its prediction are so it's adjust and improve. Difference from the linear regression use means square error. Then MSC is because it's predict a continuous value. Logistic regression predict the probabilities between 0 and 1. So MSC is the not suitable. Instead, the logistic regression use log loss, also called as a cross entropy loss, which is the specially designed for the classification problem. The log loss formula is used like a loss equals to minus in bracket y log in p1 minus y log 1 minus p close bracket. Where is the y is the actual value, actual label 0 and 1, or 3 is the predicted probability of class 1. How it's work? If the model is predicted correctly, example y equals to 1 and the p approximately 1, the loss is very small. If the model prediction is incorrectly, example y equals to 1 but p is not equals to 0, the loss is very large. So minimizing the loss ensures the model predictions match the actual labels as closely as possible. Initiation, think of the punishing wrong predictions more heavily than correct prediction. The model adjusts its weight coefficient to reduce the loss across all training example. The smaller to the loss, the better the model is the predicting the correct class. Example, suppose actual label y equals to 1 positive class, the predicted probability equals to p equals to 0.8. Log loss equals to minus 1 point log 0.8, 0 point log 0 into log 0.2 equals to probability 0.22. So by minimizing this log is a logistic regression model, learn the best coefficients make we are using. Gradient descent is used to optimize the model. Steps, initialize the parameter, calculate the error, update the weight, repeat until convergence, and this improves the model accuracy. The types of the logistic regression. There are the three types of logistic regression we will see. First is the binary logistic regression, second is the multi-nominal logistic regression, and third is the ordinal logistic regression. Binary logistic regression. The two possible classes we will see, this is the binary logistic regression. Two possible classes, example spam, not spam. There is a spam, not spam, yes, no, pass, fail, most common types. This is the binary logistic regression. Okay. Then the next one is the multiple logistic regression. The multiple logistic regression, more than two classes we will see. First is the example image classification. The image classification is like B, cat, dog, horse. Then it is the yes, multiple cases like classification. We will use it. Okay. The binary logistic regression we will see is spam, not spam, emails, loan is approved or rejected, student pass or fail, customer churn or not churns, or medical is the positive or negative. In this all these cases, output is either one or class are the others, never something in between. Why it's important? Binary logistic regressions is the most common type because many practical problems can be reduced the yes, no, and true false question. It's also similar to train, visualize, and evaluate it, making it great starting point for the understand logistic regression. Transitioning to next slide, we will multiple logistic regression see. There is the multiple logistic regression, more than two classes, like a binary regression used to only two possible outcomes as a binary two class. Examples emails and loans. But why it's common as the binary? But there is the next one is the logistic, and we will see the multi nominal logistic regressions. There will be the more than two classes. Okay. And that's what is meant by the more than two classes, and what is the difference between the which one first is the binary, and there is the multiple logical regression. When we have two or more classes, we have multi-logistic regression. Instead of predicting just yes, no, the model predict the one of the many categories input to. It is the image in the cat, dog, and horse. The model looks features images, assign a probabilities to each class. This class will be highest probability become the prediction label. Cat is 0.2, dog is 0.6, and horse is 0.2. The final prediction is the dog because the highest probability. Why it is used? Recognize handwritten disease, predict the product output types, e-commerce website, and classify the new articles into topics. There is the use of there and ordinal logistic regressions. The third one is the ordinal logistic regression. There is the order of the relation. Order of the relation is like the hierarchy, and there is the connection between the two outputs. The first is the class orders. Sometimes the class we want to predict have a natural order and ranking. This is the ordinal logistic regression coming. Sometimes the class we want to predict have the natural and order ranking. This is the value ordinal logistic regression coming. Unlike the binary or multinomial logistic regression, the order will be the class matters, but the exact distance between they may be not uniform. Example: poor is 1, average is 2, good is 3, and excellent is 4. Here the rating are ordered from the worst to best. Poor is less than average, is less than good, and less than excellent. Poor, average, good, and excellent. This is the understand the good is the higher than average, unlike the regular multinomial classification, which treats all the classes as independent. Applications. Ordinal logistic regression is useful in a many areas. Customer satisfaction survey, poor, excellent. Employee performance evaluation like HULT. Scale responses in research, strongly disagree and strongly agree. Yes. Then next one is the model evaluation. To evaluate the model performance, we use the accuracy, precision, recall, effort score, and confusion matrices. Okay. Real world applications we will see. There is the real world applications. Logistic regression used as a many fields, and we will see it likely one of the most widely used classification algorithm because it is a simple, interpreted, efficient. First is the healthcare is the decision prediction. Predict the whether a patient has a disease not based on the symptoms, medical history, or a lab result. Example: diabetes, heart disease, or cancer prediction. Helps the doctors make early or informed decision. Second one is the finance credit risk analysis. Bank use the logistic regression to predict where a loan is applicant is likely to default based on the features like income, credit score, past payment history, help in reducing financial risk. Third one is the marketing is the customer churn prediction. Companies predict the where the customer is likely to leave service based on the usage patterns, purchase the history, and complaints. Helps to business and retain the valuable customer is the pro- proactively. And the fourth one is the spam detection, email spam detection. The logistic regression can classify the emails as a spam and not spam. Okay. It is analyze the features like a slender, keywords, email, frequently, help in keeping inboxes clean and reducing the security risks. Okay. Keywords is the logistic regression is a simple algorithm, extremely powerful and widely used in real world decision making across the industries. Come to the next part is the logistic regression in Python. From sklearn linear model, import logistic regression. Model equals to logistic regression model fit X train, Y train, and predict the model prediction values. The sklearn is the library of the machine learning There is the linear model import from the logistic regressions. Model is the logistic regression. The data is the classified to X train and Y train, and the prediction model predict the X test. The last one is the conclusion. We will see in this seminar what is the conclusion. Okay. The key points is the logistic regression is the classification algorithm. Logistic is the primary used to classification problem. The sigmoid functions we will see used to how to use sigmoid function, linear combinations, features, and then apply the sigmoid function. This transform the output into probability between 0 and 1. Then output probability values, instead of the predicting the class directly, is predict the probability of belonging to class. Based on the threshold commonly 0.5 and the probability is the convert into final class labels. The fourth point is the widely used in machine learning applications. Logistic regression used to across the healthcare, finance, marketing, cybersecurity, and many more. Example include a disease prediction, credit risk analysis, spam detection, and customer churn prediction. One of the most fundamental algorithm, despite being a simple, it is extremely powerful and survey as a foundation for a learning more advanced machine learning model. Understanding logical regressions give you the building block for classification and probability model. Mm. The understanding logical regression, logistic regression gives you the building blocks for classification and probability. The probability modeling, and this is the block of the classification. We will see all this PDF. We will see this all this PDF, the linear regressions, logistic regression algorithm. Last webinar, we will see the linear regression, and this we will the logistic regression. We will see. Okay, the logistic regression is the data classification and use for the data we were using. What is the supervised machine learning algorithm? Classification problems, predict probabilities, increase instant predicting probabilities, instant belong to class, computer a linear combinations feature, applies the sigmoid functions, thresholds. Then we will see the type of logistic regression: binary, multinomial, ordinal, two classes, more than two class, ordered classes. We will see the excellent rating. Model training is define the best coefficient using maximum likelihood estimation like MLE. Then we will see the last one is the optimized log loss cross entropy. Then we will see the applications like healthcare, finance, marketing, email. The healthcare is the disease prediction, finance is the credit risk assessment, marketing is the customer churn prediction, and email is the spam detections. Key points is the output probabilities for the class and widely used to fundamental algorithms, data science, simple interpreted form of the foundations. There is the last, we will see the last one line is the closing line for this webinar. It's logistic regression is a simple yet powerful. It is a predicted probabilities and separate class and effectively to the widely use of a real world application. Mastering the algorithms is the great first step in the data science journey. Okay, thank you.